What's up guys, this is Massey. Welcome to another video. Let's have some examples regarding evaluating logarithmic expressions. First example, I have log 135 base 3 subtract log 5 base 3. You can use quotient law. 135 over 5 base 3 is going to be 27 base 3. 27 is 3 cubed, so we can write it as 3 times log 3 base 3, which is going to be 3 times 1 equals to 3. So I use 3 laws. One law is log A base C subtract log B base C equals to log A over B base C. Another law is log A to the power of B base C is going to be equal to B times log A base C. And the third law I use, log A base A is always equals to 1. Next example, log 10 base 5 plus log 2.5 base 5 equals to, again we need to use the product law because we have addition. 10 times 25 and 2.5 is going to be 25, and 25 is 5 squared. So we can move it there, and it's going to be log 5 base 5. So 2 times 1 is going to be equal to 2. Next one, log 50 plus log 2 equals to log 50 times 2, and that's going to be log 100. When the base is not shown, it means that the base is 10. So log 10 squared is going to be 2 times log 10, and log 10 is 1. So the answer is going to be 2 times 1 over 2. Next one, log 4 to the power of 7 base 4. You're going to say that's going to be equal to 7 times log 4 base 4, and that's going to be equal to 7. Next example, log square root of 10. We're going to say that's going to be log 10 to the power of 1 over 2, which is going to be 1 over 2 times log 10. Log 10 is 1, so the answer is going to be 1 over 2. What about cube root of 10? That's going to be log 10 to the power of 1 over 3, which is going to be 1 over 3 times log 10. That's going to be 1 over 3 times 1. What about log cube root of 10 squared? That's going to be log 10 to the power of 2 over 3 is going to be 2 over 3 times log 10, and that's 1, so the answer is going to be 2 over 3. Next example, log 5 to the power of 3 base 25. I need to make these two are the same. Instead of 5, I'm going to write 5 squared, so this one's supposed to be 3 over 2, because 3 over 2 times 2 is going to be 3. Then I can change it to 25 to the power of 3 over 2 base 25, and that's going to be 3 over 2 log 25 base 25. That's going to be equal to 3 over 2. Next example, log 54 base 6 plus log 2 base 6 plus subtract log 3 base 6. That's going to be log 54 times 2 divided by 3, which is going to be log 36 base 6. 36 is 6 squared, so I can write it as log 6 squared base 6. And then you move the exponent there, is going to be 2 times log 6 base 6, and that's going to be equal to 2. Next example, it says log 6 root 6 base 6. You can say that's going to be equal to log 6 times 6 to the power 1 over 2, because the square root is the same as 6 to the power of 1/2 base 6. When you multiply that, it's going to be 1 plus 1/2 is going to be 3 over 2 base 6. So 3 over 2 times log 6 base 6 equals to 3 over 2. Next example, log 2 base 8 plus log 3 log 2 base 8 plus 1 over 2 log 16 base 8. So that's, you can write it as log 2 base 8 plus log 2 to the power of 3 base 8 plus log 16 to the power 1/2 base 8, which is going to be log 2 base 8 plus log 8 base 8 plus log 4 base 8, which is going to be log 64 base 8, and that's going to be 8 squared. That's going to be equal to 2. Next example. Log root 36 base 2 subtract log square root of 72 base 2. That's, I can use quotient law, so log root 36 over root 72 base 2. That's going to be log square root of 1 over 2 is 2. In other words, it's going to be 2 to the power of negative 1/2 base 2. So negative 1/2 log 2 base 2 is going to be negative 1/2. Next example. Log 54 base 3 plus log 3 over 2 base 3 is going to be log 54 times 3 over 2 base 3. That's going to be log 81 base 3. 81 is 3 to the power 4. So that's going to be 4 times log 3 base 3, and that's going to be equal to 4. Next example. Log x base 2 equals to 2 times log 7 base 2 plus log 5 base 2. That's going to be log x base 2 equals to log 7 squared times 5 base 2. Therefore, x is going to be equal to 49 times 5, which will be 245. Next example is log x equals to 2 times log 4 plus 3 log 3. We can say that's going to be log x equals to log 4 squared plus log 3 cubed. It's going to be log x equals to log 16 times 27. And 16 times 27 is going to be x equals to 432. Next example. Log x base 4 plus log 12 base 4 equals to log 48 base 4. So we're going to say log 12x base 4 equals to log 48. So we have x equals to 48 divided by 12, which is going to be equal to 4. Next one. Log x base 7 equals to 2 log 25 base 7 subtract 3 log 5 base 7. That's going to be log x base 7 equals to log 25 squared base 7 subtract log 5 cubed base 7, which will be log 25 squared is 5 to the power 4 divided by 5 to the power 3. So because we can use the quotient law. 5 to the power 4 divided by 5 to the power 3 is going to be just 5. Both sides are the same, their bases are the same, so x equals to 5. Next example. Log x base 3 equals to 2 log 10 base 3 subtract log 25 base 3. I can say log x base 3 equals to log 10 squared base 3 subtract log 25 base 3. So log x base 3 equals to log 100 divided by 25 base 3. So log 4 base 3. X is going to be equal to 4. So these are some examples I wanted to show you in order to use some laws of logarithms in order to solve for x. I hope you enjoyed this video. Please don't forget to subscribe to this channel. You can have access to many other videos regarding logarithms and logarithmic functions and other topics in math, chemistry, and physics. Please leave me a comment if you have any question, and I get back to you as soon as possible, and I will leave some related videos and playlists in the description for extra practice question. Thank you for watching and have a great day.